Boolean minimizations, we had seen that there are several variations that simply we can say that we are been facing a problem in what way and when to apply the Boolean laws and what Boolean laws are needed to be utilized. So that is the major problem there. So, and we had discussed the standard format of expressions. So sum of products and product of sums and min terms as well as max terms. So now we are going to discuss, and we had a introduction to the maps also. Now we will be moving on to the problematic part of this Boolean algebra. So what are the previous gate questions that are being asked in this concept of Boolean algebra? So just a moment, I'll share the document to you so that how the questions will be there. Now I'm going to share you a document. So here, the first question is, it is a GATE 2010 question that has been asked here. So a function is been given and that function is been represented by three variables P, Q, R, and the Boolean expression is been given as PQ plus QR bar plus PR bar, and you need to find it out the min term expressions for it. So this is the question that is been given to us. I'm going to, so which means that it needs to be converted into standard form. So in what way we need to convert it into standard form? Yesterday we had seen that if an expression is, if a variable is been missing in a product term, that variable needs to be ANDed with an OR term. Remember, a variable which has been missing in a product term, that variable should be ANDed using an OR law. So here, if you see that, I'll be opening a document for you in order to do this problem. So I'm writing the question. So this is the question. Now what is that is here? I'll be having PQ into R plus R bar plus I'll be having 2R bar into P plus P bar plus PR bar into P plus Q bar. So this is what the expression. So a variable which has been missing in a product term, that should be ANDed with an OR term, OR law. So now after placing it in this way, simply you need to multiply it. PQR plus PQR bar plus PQR bar plus P bar Q R bar plus whenever you are writing, use commutative law, maintain the same order. What is that you have been maintaining from the first? PQ R bar, P bar R bar. And now check if any repeated terms are there, because A plus A, you are going to have A itself. So PQR bar, as it is been repeated this, I'm going to consider only one time. Now there are 5 terms that are being there here. Again, one more term is the PQR bar is also repeated. So I has eliminated. How many terms are there? There are 4 terms. And I said, if it is the expression is sum of products, then we will call it as min terms. In min terms, what is that? We will be considering complement of the variable will be considered to be as 0 and complement will be considered to be as 1. So here PQR means triple one, and PQR bar means 010 plus P bar 2 R bar is 010, P Q bar R bar is 100. So which is nothing but M7. So triple one means you are going to have M7, 7 comma, and it is 6 comma 2 comma 4. So M2, M4, M6, and M7. So you can cross check that the option is going to or not. So that is the first option that is being there. So that is the answer for it. Coming to the second question. In the second question, so you are being given with a diagram, circuit diagram, and you need to analyze this circuit diagram and you need to write the expression for it. So if you observe here, it's a simple calculation where you need to consider what is the output in what way it should be written. So the first case, in the first level, you are going to have 4 NOR gates, and in the second level, you are going to have 2 NOR gates, and in the third level, you are going to have 1 NOR gate. So the first thing, simply whenever these types of expression is being given, always you need to remember only one thing. On the basis of levels, you need to do the problem. So it's simply problematic. So first level, the first gate is always considered to be as P plus Q bar. Remember, the first gate output is P plus Q bar. So this is the first gate output. Then it comes to the second gate. It is QR are the inputs. So the second gate output will be Q plus R. So both these gates, first level, both these gates are being given to another NOR gate. Remember. So in between these two, I need to have a sum, and these two needs to be complemented. Seems to be complex, but it is very easy. People need to consider that. So this is the first expression. And coming to the second expression. So this has done first level 1 2 gates, and in the second level first gate. Now I am moving to do the analyzation for the first level 3 4 gates and the second level second gate. So P plus R bar. So P plus R whole bar, Q plus R whole bar. P plus R bar. What will be the next expression? P plus R. The next will be Q plus R. Q plus R. So these two gates are connected to another NOR gate. So that is the reason here I need to take it as a plus symbol, and again I need to close the bars. So it will be complement, 4 complement. So here it is clear. Now I has done first level Whereas second level also has done it. And coming to the third level, again it is these are connected to the NOR gate. So in between this, I will be having a plus symbol and complement to the whole term. So I need to consider brackets. So this is a complement to the whole term. And whenever you want to do this problem, first you need to apply De Morgan's law. So on applying De Morgan's law, what happens? A plus B whole bar. It is nothing but A bar into B bar. So I'll be having plus Q whole bar plus 2 plus R whole bar. So this is the term that I'm going to have because complement to complement will become the same term. So I'll be left over with this term. And in the second case, what is that is I'll be left over with the terms plus R whole bar plus 2 plus R whole bar. I want everyone to do this problem because in typing it is getting delayed. If you do it, you can do it much faster. So this is what the final expression that we are going to have. And further, I need to minimize this. When I am going to minimize this, this will be P bar into Q bar plus Q bar R bar. So this is the expression that I am going to have here. Next, I will be having in the second case I will be having P bar R bar plus Q bar R bar. So this is what the expression that we are going to have, which is equal to. Now simply multiply it. Don't do anything else. Just simply do the algebraic multiplication for this. We will be having P bar Q bar R bar plus again you will be having P bar Q bar R bar plus again you will be having P bar Q bar R bar plus then you will be having, so you are going to have Q bar R bar. Going to have Q bar R bar. This is what the expression here you are going to have. So finally, if you observe that all these terms will be one itself. The leftover term, the Q bar R bar as common. So we will be having only Q bar R bar term. So which is equal to, I can write it as Q plus R whole bar. So check it out whether the option is in there. So that is the first option that we are going to have is Q plus R whole bar. So only when you practice these types of problems you will be able to do it in less time. Otherwise it takes much amount of time. And while doing the simplifications you need to be thorough with the Boolean laws. Once you are through with them, then only you will be able to apply them very easily. And coming to the next one, what is the minimum number of gates that are required to implement this AB plus C function? So the term itself says it is a sum of products expression in which you are going to have an AND gate and an OR gate. So here, if it is A, B plus C, expression needs to be represented. Then I'm going to draw it for the convenience sake. So it is AB plus C. So first, in order to count the number of gates, what is that I need to do is I need to draw the circuit for this AB. As AB is a product term, so I'll be having an AND gate that is been connected with two inputs. Now C is an individual input that I'm going to take. And as both of them are summed together, I'll be having an OR gate. So how many gates are involved here? Two gates are involved. This I need to convert it into NOR gate. So in order to convert into NOR gate, what is that I need to do is just substitute bubbles between. So as there are two inversions, so A, B will not be changed. Only the C input is going to get changed. So how many gates are required here? So two NOR gates are required for me to represent this. And coming to the next one, next problem. So an AND gate is been there as well as here an OR gate is been there. So the AND gate terms are been given here. Here everything is been represented is similar to that of a sum of products expression itself. So F1, F2 are two inputs, both are product terms. F3 is another input, I am going to have another product term. Now I need to find it out the expression for it. So what are the min terms that are being there? So simply you can observe from this diagram that if F1 and F2, F3 are defined to me, then what should be F2 value? Or simply F1, F3 are being defined and even the output function is also being defined. You need to find it out. What is F3? So for the sake of it, what is that I am going to do is that I am going to check with the output function first. So the thing I need to do is either I need to find it out the expression for the output function. If you see this, in this question, as the min terms are extended till 15, we need to consider it as a 4-variable mapping. So here I need to draw 16 square boxes for key mapping. So for f function, what is the min terms that are being given here? 1, 6, 8, 15. So 1, 6, 8, 15. So I have represented the terms, and whereas if you observe for F3 function, I am going to have 1, 6, and 15. So in output they have been present. So F1 function 4, 5, 6, 7, 8. 4, 5, 6, 7. So now, what are the additional terms that had represented F1? I had represented F3. I had represented F also. What are the additional terms that are being included here? So if you see the additional terms that have been included here in this K mapping are four. The terms which are not being mapped should be considered. The terms which are not being mapped should be considered. So here we'll be having 4, 6, 8. So this is the option that I need to select. 4, 6, 8. So fourth option that you are going to have. In that way also you can cross check it. And coming to the fifth problem that has been given us. So here Boolean variables are being given p plus q bar into p q bar plus pr plus p bar r bar plus q bar. Simplify this expression. First, you need to do the algebraic multiplication for this expression and you need to minimize it. So I want everyone to check it out. So try to minimize this. Try to minimize the expression p plus q bar into pq bar plus pr p bar r bar plus q bar. So for one is involving here, myself I'll be doing. First, whenever this types of question is being given, first you need to do product of two terms first. So for the first two terms, some terms I'm doing the product. So it will be pq bar plus, again it will be pq bar plus, it will be pr pq bar r. So for the first two terms, when I multiply, I got this expression. So as pq bar is repeated twice, I am eliminating it. So this is the expression that I am got. And if you see that in the first expression and in the last expression, pq bar plus pr plus pq bar r. So if I take pq bar as common, 1 plus r, it will be neglected. So I can eliminate this. So for the when I do the product, I am going to have this expression. Now p bar r bar is q bar be equal to. So now I'm going to do the product here. P into p bar. So I'll be having 0. P into p bar, again it will be 0. So the entire expression pq bar plus pr, if it is multiplied with p bar r bar, the resultant will be 0. So I need not consider it. The next one will be when I need to multiply with q bar. So when I multiply with q bar, the resultant will be q bar into pq bar will be pq bar itself plus pq bar, which is equivalent to pq bar. Options whether pq bar is in there. Yes, that is the first option that we have. So coming to the next question. Consider the following Boolean function. So in order to find these types of questions, so a Boolean function, 4-variable Boolean function has been given with min terms, and he's been asking whether it is being dependent or independent. So I need to cross check with the solution. So I need to find it out the solution for this. So in order to find it out the solution, I need to draw the K map. So as it is 4 variable, I am going to draw the 16 combinations or 16 minterms here. So what are the minterms that are being present here? W, X, Y, Z are the variables. So here it will be W bar, X bar. Here it will be W bar X. Here it will be WX. Here it will be WX bar. And here it will be Y bar, Z bar. Here it will be Y bar Z. And it is YZ. As K-map follows breakcode, this is the combination that I need to write. Now, in the question, what are the minterms? 1, 3, 4, 6, 9. 1, 3, sorry. 1, 3, 4, 6, 9. 1, 3, 4, 6, 9. 11, 12, 14. 11, 14. So, observe here. I'll be able to make a quad. So, when I make a quad, what will be the output expression for this? It will be, the common term will be X bar in the first row and the last row. So, it will be X bar. And in the second column and the third column, the common term is Z. So, X bar Z. And now, this becomes as a pair for me. So, what will be the terms here? It will be X, Y, Z bar. And I'm going to consider it as a group. I'm going to pair it. Then it will be W bar X. And what is the common term? Z bar. So X bar Z plus XYZ bar plus W bar XZ bar. Question that is been asked here. So independent of one variable, independent of two variables, independent of three variables, dependent on all the variables. So if you observe, what is the expression? I have all the variables. See here, X is there, Y is there, Z is there, and W is there. So the output expression is always dependent on all the variables. So here the question for this type, you need to find it out the Boolean expression by using K-maps, and then you need to decide whether all the variables are being present or not. If all the variables present, then you need to say that it is dependent on all the variables. The next question. The maximum number of Boolean functions that could be obtained from the given Boolean variables. Generally, if I am having two variables, I will be having four combinations. But here, the question is, remember, the question is related to the functions. Then it will be 2 power n. So here C is the right option. So I will be having 2 power n. Next, there is an expression that is been min terms is been given, or a function is being defined, and that function needs to be represented with an expression. And out of these four options, three options are correct, one option is wrong. So you need to find it out what is the option that is wrong. So in order to define, in order to do these types of problems, you need to go through with the options. When you go through with the options, you need to draw the K map for all these expressions. Based on which you will be able to identify what is the not equivalent term. So I'm going to take this. I'll be explaining you in what way you need to find it. సో ఎప్పుడైనా మనకి మిన్ టర్మ్స్ ఇచ్చి ఆ మిన్ టర్మ్స్ ద్వారా వచ్చేటటువంటి ఫంక్షన్ ఈక్వలెంట్ ఫంక్షన్స్ ని ఫైండ్ అవుట్ చేయమన్నారు అనుకోండి. ఫస్ట్ మనం ఏం చేయాలి అంటే ఇచ్చినటువంటి మిన్ టర్మ్స్ తోటి అవుట్పుట్ ఏమొస్తుందో చెక్ చేయాలి. అవుట్పుట్ ఎక్స్ప్రెషన్ ఏంటి అనేది చెక్ చేసుకోవాలి. లేదు, మన ఆప్షన్స్ ని మాత్రం మనకి ఇచ్చారు. ఇఫ్ ఓన్లీ ఆప్షన్స్ ఆర్ బీయింగ్ గివెన్, then what is that we need to do is we need to go with the K-map for each option. So once we go with the K-map representation for each option, you will be able to identify the min terms. If any irrelevant min term is present, remember, if any irrelevant min term is still present, then you can say that this is the not equivalent expression. So let me draw this. Once again for you. So as W, X, Y bar, Z bar, sorry, W, X, Y, Z are the terms. I'm going to consider the K-map representation. As it is 4 variable, I'll be having 16. So I'm going to take all the four expressions here. So here, these are the expressions. A little bit of blur is there. To avoid that blur, I am going to minimize it. Hope it is visible now. I'm unable to visualize. So better, let me check it out with the single option. So I'm taking the single option here. So you can observe here. It is X bar, Y bar, Z bar. So when I say that, I'm going to have these types of expression. Remember, here I will be having W. W bar, X bar. W bar, X. WX. WX bar. And if you are going to have y bar, z bar, y bar, z, y, z, y, z bar. So now the first product term is x bar, y bar, z bar. So I have y bar, z bar here. X bar is being present in the first row and last row. So when only these two min terms are grouped, I will be having that product term as x bar, y bar, z bar. The next one is w bar x. W bar x belongs to second row and it is y bar, which means that first column and second column. And the next one is x, y bar, z. X belongs to second row and third row. Y bar z belongs to, and the last term is xz. Xz means x belongs to second row and third row. Z belongs to second column and fourth column. So I will be having all the four terms and group. Now what are the min terms here? It is 0, 4, 5, 7, 8, 13, 15. So these are the min terms that I got from this expression. Now check these min terms with the given min terms. 4, have 4, 0 is there, 4 is there. What is the next term? 3, 7, 8. 5, 7, 8 is there. 13, 15 is also there. So the first expression is a relevant expression. Now, coming to the second expression, I'll be choosing the second option. So first expression is okay. Coming to the second one, w bar, y bar, x bar. W bar, y bar, x bar. So w bar, if you see here, now for simplicity, I will erase this for you so that within the same one, if I explain it, you will be able to understand easily. Now for the second expression, w bar, y bar, x bar. W bar belongs to first row, second row. W bar, x bar belongs to first row. Y bar belongs to first column and second column. So we are going to have the min terms as 1, 1. W x bar. W x bar belongs to last row. Y bar belongs to first one and last row. So this is what. And xz. Xz belongs to the quad. Now what are the min terms here? Min terms are 0, 1, 5, 7, 8, 9, 13, and 15. Now check these min terms with the question min terms. The question min terms are 0, 4, 5, 7. So 1 is not there, and even any new terms are being there. So 1 is the term that is newly included for us. So with this, as 1 is included, I'll be able to say that this is an irrelevant. So without checking the other options, I will be able to say that B is the irrelevant one. So now moving on to the next one. I have been given with a question stating that define the connective operator for the Boolean variable x and y. X star y is indicated with xy plus x bar y bar. Let z equal to x star z. Consider the following expressions p, q, r. P, P is defined as x equal to y star z. X equal to y star z. So for these types of questions, what is that you need to do is x star y. Remember, it is a simply a NOR operation, XNOR operation. Z equal to x star z. So first I am going to simplify these expressions. Then I will be able to say that which one is true. Given question, x star y is defined in this way. Z equal to x star z. Now P is defined as in this way. So let me check it out. So equal to x star z means written as xz plus x bar z bar. Here x equal to y star z, which will be equal to y bar yz plus y bar z bar. So x equal to, so this is the first expression that we had to. So the question is, so let me find it out q also. Q is given as y equal to x star y. So this is p. We are going to find q. So which is equivalent to y bar y bar. So this is y. P is being defined, Q is being defined. Now R, x star y star z. So x star z. Anything I can take. So what is that is, here I'll be taking it as Q star z. So which is equal to Qz plus Q bar z bar, which is equal to What is Q? Q is nothing but xy plus x bar y bar. What is Z? Z equal to xz plus x bar z bar plus. What is Q bar? Q bar is always x bar y plus xy bar. Z bar would also be x bar z plus xz bar. Now do the simple multiplication here. Y z xy into xz, it will be xyz. X into x bar, it will be 0. X bar into x, it will be 0 here, plus it will be x bar y bar z bar. Here x bar yz plus y bar z bar. So you need to simplify. After simplifying, what is that you are going to get? So I am going to consider y bar z bar as common in the second term and in the fourth term, and the yz common to yz plus y bar z bar common. So what is the expression that I am going to get? It is nothing but p. So the resultant is p. So check the question. Only p and q are valid. Only q and r are valid. Only p and r are valid. All p, q, r are valid. So if you observe, p and q are valid, whereas r, I am not going to get 1 as my output because I am getting it as r expression. When it is been solved, I am going to get it as p. R is always equal to p. So as I am not getting 1, r is false. Only p and q are. So this is what the expression that we are finding. So this is the same question with the given min terms, or else you need to check it out the min terms of all these four expressions, and you need to cross check whether any min terms are been not matching. So the same way, and here consider a circuit which has been given for us, and you need to find it out the f value here, then only you will be able to identify that. So for this types of questions, as I said, you need to find it out the expression. So here the expression will be, what is the question? So for the first NAND gate, x into y bar. Remember, for the first NAND gate, it is x into y bar whole bar. This is the expression for the first NAND gate. For the second NAND gate, it is YZ whole bar. The second NAND gate, it is YZ whole bar. Both of them are being given to another NAND gate, F. So here again, both of them are complementary. Now apply two more terms to it. So you will be having X by bar plus YZ bar plus YZ itself. Now which is equal to the bar AB whole bar. The bar plus B. That's it. XY bar plus YZ. XY YZ. So F is independent of X, F is independent of Y, F is independent of Z. So I'm having all the variables in my expression. You see, I'm having X term, I'm having Y term, and I'm having Z term. So I cannot say it is an independent of any variable. So none of X, Y, Z is redundant, I need to say. The switching expression corresponds to A, B, C, D. Min terms are being given. That is, you need to get the minimized expression using K-maps. And coming to the next question. So you are going to have a Boolean expression, and this Boolean expression needs to be minimized. Either you can use Boolean loss, or else directly you can use K-maps for simplification. And here, what are the essential prime implicants of the given function? So first you need to observe that essential prime implicants. What are essential prime implicants is that they should be mapped minimum one number of times. So those will be considered as essential prime implicants. So just check it out the min terms and put them in K-map and observe whether they are being mapped properly or not. Now, here is a circuit that has been given, and the sets of questions you can leave it because that is related to the old syllabus. And coming to the question, so B XOR, you can leave this question here, where we can deal it with later. And here a K-map is been given, and you need to find it out the minimum expression for it. And here, same previous question, F1 is been given, F2 is been given, and F is given, and you need to find it out F3. So first, you need to place the K-maps for all the given expressions and identify the min terms, and the min terms which are not in common have been taken as F3. And here, so NOR gates are been connected. You need to realize this NOR gate, and when you realize this NOR gate, you will be considering it as a NAND gate. So this type of questions will be given to you always in the exams from Boolean algebra. So we'll continue with the next topic in the next session. So meanwhile, you practice the minimization expressions using K-map. Okay. In the next class, we'll continue with the combinational circuits.
Hello, sir.
Yes.
సార్ మెటీరియల్ పంపించగలరా ఏమన్నా ఇఫ్ యూ డోంట్ మైండ్?
నేను పంపిస్తానండి, బట్ ఇప్పుడు కాదు. ఇన్ ద నెక్స్ట్ క్లాస్లో పంపిస్తాను. నెక్స్ట్ క్లాస్ ఇప్పుడు మనకి లాజిక్ గేట్స్, నెంబర్ సిస్టమ్స్, బులియన్ ఆల్జీబ్రా 3 టాపిక్స్ అయినాయి. ఈ 3 టాపిక్స్కి సంబంధించినటువంటి మెటీరియల్ని నేను ఫార్వర్డ్ చేస్తానండి, మేడంకి పంపిస్తాను.
ఓకే
మేడం
ఓకే
దగ్గర
థ్యాంక్
కలెక్ట్
థ్యాంక్
చేసుకుంటాను.
యూ సార్.
Thank you. We'll meet in the next class.